Hello. Welcome to my channel. In this video we introduce the Cartesian coordinate system in a plane. We have two perpendicular oriented lines. And we have named them x-axis and y-axis. A point in the plane is described uniquely by a pair of numbers that are called coordinates. The two coordinates represent the distance of the point from the two axes. So for example the point P in figure have coordinates 3 and 2. Where 3 is the distance from the y-axis. And 2 is the distance from the x-axis. The first coordinate, the distance from the y-axis, is called abscissa, while the second coordinate, the distance from the x-axis, is called ordinate. The point where the x-axis and the y-axis meet each other is called origin. It has coordinates 0, 0. A point that lies on the x-axis has the ordinate equal to 0. Like the point M in figure. The distance from the origin of the points with ordinate equal to 0 is just the value of the abscissa. In our case 4. Similarly, a point that lies on the y-axis has the abscissa equal to 0. Like the point N. And the distance from the origin of these kind of points is the value of the ordinate. In our case 3, we have said that the abscissa and the ordinate represent respectively the distance from the y-axis and the distance from the x-axis. They are actually signed distances, because they can assume even negative values, while the distance is normally a positive number. For example, the point Q in figure has coordinates -4 and 0. The distance of the point Q from the origin in this case is -x1. Just because the normal distance is a positive number, while the abscissa here is negative. We ask ourselves now, how do we calculate the distance from the origin of a generic point? Let's consider the generic point A of coordinates x1 and y1. We draw the segment perpendicular to the y-axis that meet the x-axis in the point D. With the point D that has coordinates x1 and 0, we have now a right triangle. The triangle OAD. And the distance from the origin of the point A is the hypotenuse of this right triangle. We know that the length of the segment OD is equal to the distance of the point D from the origin. That is x1. If we draw the line parallel to the x-axis, this line meets the y-axis in the point E of coordinates 0, y1. The length of the segment AD is equal to the length of OE. And this is just equal to y1. So if two points have one of the two coordinates in common, the distance between these 2 points is equal to the difference between the values of the other coordinate. In order to calculate the distance OA, we apply the Pythagorean theorem to the right triangle. Then we substitute the values of OD and AD, and we get the expression for the distance from the origin of a generic point. Eventually, we are going to prove the formula for the distance of two generic points. We start by retrieving the case of 2 points that shares one coordinate. We have the point F that shares the y-coordinate with the point A. At this point, if we calculate the distance subtracting the values of the x-coordinates, we notice that we get 2 different values, depending on the order we choose. In one case we get a positive number. In the other a negative number. We know that the distance must be a positive number. So we define the distance between 2 points that shares one of the 2 coordinates as the absolute value of the difference between the values of the other coordinate. The absolute value of a number k is equal to k if k is positive, while it is equal to -k if k is negative. In this way the distance is always positive and it is independent from the order we choose to apply. Having made this necessary clarification, we finally try to understand how we can get a formula for the distance of two generic points. Let's consider the point A of coordinates x1 and y1, and the point B of coordinates x2 and y2. From each point, we draw the lines parallel to the two axes that meet the other axis. Then from the point B, we extend the line parallel to the x-axis, until it meets the line parallel to the y-axis drawn from the point A. If we call C this point of intersection, it has coordinates x1 and y2. Furthermore, we have constructed the right triangle ABC, whose hypotenuse is the distance between the points A and B. If we knew the values of AC and BC, we would apply the Pythagorean theorem to get the value of AB. But the point C shares the x-coordinate with the point A, and the y-coordinate with the point B. Therefore we know the values of AC and BC and we can proceed. When we square the values of AC and BC, we can eliminate the absolute value, because the square of any number is always positive. In the end we come to the conclusion that the distance between two generic points is equal to the square root of the sum of the square of the difference between the abscissas, and the square of the difference between the ordinates. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.